Welcome everybody to the online meetup. Today with us is StackStorm. We're going to talk about automating OpenStack clouds and beyond, obviously with StackStorm. Earlier this summer we did a session with StackStorm's CEO Dimitri Zimin, who surveyed 20 OpenStack automation projects in an online meetup. At the same time, StackStorm was not ready to talk about their software, which was only available to private beta users. StackStorm software is now freely available at StackStorm community, and the company is ready to demonstrate their open source software. So today, CEO Evan Powell and DevOps engineer Patrick Holboom will discuss problems with existing automation that motivated the development of StackStorm, followed by a demonstration of their automation as a service software, in which they will showcase the end-to-end resolution of a common OpenStack problem, as well as applying a similar solution workflow to AWS. StackStorm is not OpenStack specific, so Evan and Patrick will demonstrate integrations, event handling, decisions via rule engine, and workflows applied across OpenStack and non-OpenStack infrastructure. So with that said, just a few words about the logistics. In case you have any questions, feel free to ask those during the presentation and demo in the chat window in the left-hand side. And the presentation as well as the recorded session will be available within 24 hours after this meetup. So with that said, Patrick and Evan, the stage is yours. Can you please introduce yourself?
Yeah, sure. This is Evan Powell, and thank you very much, Raphael. I'm Evan Powell, co-founder of StackStorm, and look forward to having a conversation with you guys. And hopefully, we do keep it open and conversational. So do ask questions. Patrick.
Yeah, I'm Patrick Holboom. I'm a DevOps engineer here at StackStorm. I spend a lot of time working with these type of systems over the past decade, and I'm really excited to be able to deliver a solution like this to you guys.
So with that, why don't we dive in? I'm going to sort of set the table, if you will, and Patrick's going to walk through not one, but two demos about how StackStorm can be used. And so in setting the table, what I'm going to try to do is explain why this idea. This is the third infrastructure software company that I've helped get off the ground. They tend to be 5-6 year commitments, something like that. So why did we decide to spend the next several years of our lives building StackStorm? And that's sort of what we're going to talk about. We're going to also dive into how does it work a little bit, and as I said, hit you with a couple of demos. The first point is pretty darn high level. If this is your environment, StackStorm helps wire it together. And a little more specifically, what StackStorm has got, which is a little bit unique, at least as far as we could tell, is the ability to process events via sensors, which again we will demo for you. The ability to then use a rules engine to decide, hey, I see these three things happening. I want to go do X. So some conditional logic capabilities there. And then when you decide to go do X, it's not just a one-off. It can be a long-running workflow, which itself can have conditionality embedded inside of it. And then it can take those actions. Now, those actions can be taken by our forthcoming SALT integration, existing Puppet integration, and so forth on the right side. On the left side, sensors. What are we listening to? I think we're going to show a couple options, a monitoring solution where we're listening to events, but we're also going to show your code repository. So maybe there's a new check-in. So what did we see? So why this? Why is this a good use of so far 14, 15 months of engineering time with a real, we think, great engineering team? This is a quick one. The good news, bad news of automation today. You guys are all living this. Thank you, OpenStack. And we are going to talk about our OpenStack core here in a second, incidentally. OpenStack and other drivers of automation enable, for example, really complete APIs down at the infrastructure level in the case of OpenStack. These are all open source as well, all great drivers of automation. Developers in operations, DevOps, also really great for automation. Cloud itself and what Amazon is teaching us all specifically, really tremendous drivers of automation. So why? Is automation fixed? Well, it turns out that for the kind of use cases we're talking about, where you're tying events with some conditional logic to actions, probably 95% of those automations today in the folks that we've chatted with and our users, and a couple thousand downloads we've had, are done via scripts. They're not done via some sort of packaged existing solution. And so scripts are great, and they're fast to get going with, but they can be a pain in the ass to maintain, as we all know. So part of the pain that we've seen is especially medium to large operators needing to go from a bit of a mishmash of scripts tying events to actions into real software. And we think the broader community probably doesn't want to write their own automation platform, their own workflow, their own conditional logic, their own sensors, et cetera, et cetera. So let's provide that. Automation run amok can be horrible. We've heard all sorts of cautionary tales about automation really losing trust. So we're going to hopefully demonstrate here to you how transparency, we think, can lead to improved trust in your automation. So the first thing that happens when strange stuff starts to happen in many environments, most environments maybe, is somebody steps up and says, turn off the automation. We want to make sure we're troubleshooting a real issue, not an automation issue. So again, lots of scripts, hard to maintain, a lot of fear around automation that can kind of run amok. Two more quick points before we get into the what. So, and we'll actually show you a diagram right off of docs that shows how StackStorm works here in a second. One point, there are lots of solutions out there from the legacy vendors, by which I mean our friends at CA and IBM and elsewhere, HP of course, that do automation already, but they don't fit into the DevOps workflow. They don't treat infrastructure as code. So they can take your automations, suck them in, but you can't share those as code. Second point is, while they are happy to automate you and your environment, you cannot easily automate them. We know this space of the legacy existing automation solutions quite well. My co-founder, Dimitri Zamin, our CTO, ran engineering at Opolis, which is now Microsoft System Center Orchestrator. After that, he ran a big chunk of vSphere engineering. He ran vSphere client at VMware. So we know that space. And what we found is they have basically zero adoption in today's more dynamic, if you will, DevOps environments. And that last point is just holy smokes. I mean, the pace of change of the environment, the number of commits happening up at the application layer, even the number of changes happening at the infrastructure layer are massively greater than back even 3, 4, 5 years ago. So you do need a new architecture that can handle the scale, but can also get you to some level of automation faster. Because if you take 3 months mapping your processes, which is sort of the old run book approach, you're probably going to miss the window at which those processes as automation would be helpful anyway. Your infrastructure, your team, your DevOps environment have moved on. Net, automation is becoming technical debt in way too many environments. Let's take an open approach that ties events to actions so we can all get behind, again, a community. And one key point, this is the orange at the bottom here, is OpenStack is a great community. We contribute there. We've really been inspired by them and a bunch of others to be all open source. We're Apache, so grab the code, use it. have at it, complain about it, tweet about it. This is all open source. I'm not going to spend the next 5-10 minutes walking you through all of the key capabilities. I'll just highlight a couple here. Workflow, we've talked a little bit about, and that does come out of OpenStack's Mistral project. ChatOps, actually my colleague will be speaking about ChatOps tomorrow at the San Francisco DevOps Meetup. And we're really excited about having bidirectional integration with chat. That's part of transparency, we think. So is audit, part of transparency, and we'll show you a little bit about that here in a second. The right side is benefits. I mean, mileage will vary. Try it. Go to stackstorm.com/community. Have a look at it. We released 0.6 this week. But the idea is you should have more transparency around your automation. You should have more control, thanks to the magic of infrastructure as code, StackStorm, and the content inside. The automations themselves will fit into your CI/CD process, whatever your process is for getting code built and deployed, which is radically different than older automation solutions. Take a look at it. I'm not going to walk you through this architecture other than to say you can see integrations on one side of it. You can see that this is sort of your classic scale out with a message queue in between. And transparency is not just about what we bring, hopefully, as a product, but it's also, again, how we're building the product. So this particular image is available from Docs. So take a look at Docs. And again, give us feedback on them, contribute to them, etc. And here you can see where Mistral, as I said, from OpenStack, and we do help really working with our colleagues at Marantis and others on that project quite a bit. You can see where Mistral sits in this overall architecture. So any questions about why we set off on this journey, and at a high level what StackStorm does before I kick it over to Patrick to run through a couple of demos? Not seeing any questions pop up. What we're going to demo here, what Patrick really is going to demo for us, is first a troubleshooting. I apologize for that hanging G. Troubleshooting remediation, where you're going to see Sensu telling StackStorm something's amiss. And the underlying cloud in this case that we're acting against is an OpenStack cloud. Then we're going to flip over and do effectively CI/CD of one of our favorite applications, that being StackStorm itself. And here, and Patrick can correct me here if I'm mistaken, but I believe we're listening to GitHub as a source of events, which our sensors would be listening to. And the underlying cloud in this case is Amazon. Quick point, when I'm belaboring the point about infrastructure as code and how we embrace that, what that means is sensors can be easily shared as code, actions can be easily shared, the automations themselves that tie the two together, they're just slices of code. And if you already have some scripts, don't throw them out, or at least not yet. StackStorm can start with those, ingest them through some magic, either manually or through a utility we have, and they can become actions, which now you can tie together with workflow. So don't get rid of those scripts, repurpose them, put them into this platform, which will help you manage them, tie them together, do all the other sort of feature things that I mentioned before, audit, controls, GUI, CLI, ChatOps integration, and so forth. So with that, Patrick, I'm going to hand over to you. We do have one question. Which, yeah.
Okay, you want to read that out to them?
Now, what is different from SaltStack or Ansible? This is a great question. What we are seeing so far is two things. If you dig into the event handling capability, which here we're calling sensors in this drawing, but really there's sensors and triggers and rules underneath here. And B, the workflow itself. In both cases, that's been our focus, and those are quite rich, powerful, extensible. Not to say that Salt and Ansible don't have flavors, not so much on the event handling from external events yet, or that they won't as of yet. But today, of course, if you look at those communities and those solutions, they're much more focused on remote event execution. In other words, I have 1,000 servers or 100 or 10, whatever. I want to do something to them all. That is really their focus. Our focus is more about what do you want to do and how do you wire that together with events, with a super powerful extensible workflow. So we're more a little bit more the brain tying things together, and they're a little bit more focused on actions, but obviously we're learning quite a bit from both of those projects.
Good, yeah. So I'm going to try and share my desktop here and get us going.
Is it working, Patrick?
All right. Can everyone see the proper screen there?
Yeah, it looks very good, Patrick.
Okay. All right. Perfect. Okay. So the first demo that I really want to show to you guys was I wanted to show an OpenStack remediation workflow around a underlying hardware issue on a Nova Compute node. The general idea is that you have a Sensu server sitting out there that's monitoring various hardware pieces or things like that, and it emits an event, and that event is consumed by our system, and it fires off a remediation workflow to help alleviate the on-call engineers from a lot of the manual tasks that they would normally do during that. So if we actually take a look at that event, and I will dig into the specifics of what these various pieces mean, the triggers and the actions and how they're actually put together in a moment. But overall, I wanted to show the capabilities of the system before we dug into the command line interface and looked at the specifics of it. But you can see here for this particular event, Sensu emitted a hardware alert, and that hardware alert came into the system with a standard Sensu data format, and it told me that there was a hardware problem on the Compute 2 host, and then it went ahead and it fired off a workflow that we have here called Evacuate Compute. What Evacuate Compute did was it went and it got all of the Nova instances that were on that particular compute node. It got the owners for all of the instances. It sent mail to all of those people saying there was a problem with the underlying hardware. We're going to go ahead and migrate the VMs. It marked the compute services disabled on that node. It migrated the VMs, and then it confirms the migration for all of those VMs. So the beauty of something like this is kind of what we refer to as automatic remediation. It allows you to go ahead and take an incoming event, whether that's something from Solometer or Sensu or Nagios or anything like that, perform a set of remediation actions against your infrastructure and kind of reduce the firefighting that's needed. Take the top level events that you're going to do during a remediation scenario, tie them together into a workflow and perform those. You can then submit a JIRA ticket or a Bugzilla ticket to replace the underlying hardware the next morning. So you don't have to get up and do these things at 3 a.m. You can do them the next day if you want to. If we actually go over and we look at the workflow itself, we can see this is the standard Mistral workflow as is defined. It's just a YAML definition of a workflow that tells you all of the individual tasks that get fired off during that workflow and the parameters that get passed between them. That's kind of a key point, is that the beauty of the workflow is that it does have a shared context so we can pass parameters between them. Evan likes me to kind of come back around to the so what of it all. The so what of it all is that this is something that I would do if I was to be troubleshooting this particular instance at 3 a.m. and I was the on-call engineer. But by having this workflow codified here within the system, I now have a full audit trail across this with the history, seeing exactly what happened, when, and what the trigger was that fired that off for us. This is a pretty general, basic workflow. I mean, I took the steps directly from the OpenStack troubleshooting guide, and I just translated them into a workflow that we could show that would seem relevant to this audience. The one that's actually much more interesting to me is what I've recently been working on, which is the CI/CD pipeline, what we refer to as StackStorm building StackStorm. So hey, Pat, we actually take, yeah, go ahead.
Yeah, yes. just quickly. So key point there that Patrick touched on is, where did this automation come from? Well, it came from the sort of collective wisdom of the incredibly large OpenStack community and the troubleshooting guide specifically. And this is just a great case of where we had, frankly, some seed corn to start with in terms of figuring out what to automate. And while this is a particular page out of the troubleshooting guide, if you will, or entry in the troubleshooting guide wiki, we have others. And so if you're looking to kind of offload some of the ops guys' time and, pager fatigue is something you're talking about, being able to address common issues that have already been pretty well understood, well enough understood to warrant a page or an entry in the wiki troubleshooting guide, and then automating those, that might be a good way to go. And again, we've already done this automation for most or many of those. So that's a point I wanted to make. Now, I guess it goes without saying that domain knowledge that the community has thrown out there in the wiki is not always as easy to grasp in other areas. And so that's where it's really critical for us to make it relatively easy for you to tie together these underlying actions. So you may have some other workflow that is not as clear-cut as how to evacuate a Nova compute instance in reaction to Nova losing its mind or having failure. We just had a question around workflow. Do you want to take it? Or I happen to know the answer to this, but Patrick, you can probably give it a better answer. Do you see it?
No, go ahead. Once I started sharing my screen, I didn't see the question, so if you want to answer that.
Yeah, it's just can the workflow actions be performed concurrently? And the answer is yes. And Mistral, this underlying OpenStack workflow as a service project, actually enables also some looping capabilities as well. So it is quite powerful, and a lot of what StackStorm's bringing to the table here is how to improve usability, audit, etc. But the underlying engine is quite powerful.
Yeah,
speaking of audit,
I was saying that's really great. And actually, the parallel workflows can get quite interesting. You can run some fairly advanced parallel workflows through the Mistral engine, and then you can use those as a point that then can emit triggers back into the system to create another complex workflow that allows you to do some really neat things around branching and waiting for a full complete context around the workflow before proceeding.
And this workflow, of course, includes the ability to, via chat ops, et cetera, or via ticketing, or via email, or Twilio, SMS notification, or to involve the humans explicitly in the workflow. So that's an attribute of a good workflow system. But I wanted to highlight that as well. You're in an environment where doing CI/CD, but the CD involves let's wait for the human and make sure it's okay, or even facilitated troubleshooting. You really need we think, a powerful workflow engine to be able to pull in the human. Human obviously runs slower than software, and you're not sure when they're going to respond. So those kinds of capabilities require a good workflow engine, in our opinion. Patrick, I interrupted you. You're about to do the CI/CD pipeline factory. Take it away.
Yeah, sorry. So as I said, this is the one that I've been spending a lot of my time working on here as we move into using StackStorm itself to build StackStorm. And so a lot of the jobs that I would normally do through other CI/CD tools, I've moved into our system. And so I've created a workflow that goes through and runs all of our tests that we would normally run throughout a build process. This looks fairly complex, but really it is very simple. What it is this is just once again a linear flow workflow, but it's a linear flow of cloning our repo and building a virtual environment and provisioning that virtual environment with all the requirements. And then going through and running all of the tests that we need to run against our platform before we decide that we can move on down the CI/CD pipeline to do the packaging and things like that. It's been incredibly easy to write this workflow through the system, and it's pretty neat actually. It's one of the things that I really am proud of, that we're able to do this through the system. And then it allows me to move on to the next piece of our pipeline here with the CI/CD, which is we have out there, if anybody wants to actually try out our system, we have a repo out there called SD2 Express. And so one of the important pieces around our SD2 Express repo and our quick start guide was I needed a way to have a very good continuous integration testing around that. And so I built a workflow that actually would spin up that environment upon each commit to the top of the branch, to the master. And so it actually goes, and this actually is a good example of something outside the domain of OpenStack a little bit, because what I'm doing here is I'm spinning up an AWS instance. I wait for the instance to come up, and you can see the parameterized nature of the workflows here. It's just Jinja templating. I'm able to take the output from the first instance and parse that down, looking for a particular field within there. And so I'm looking for the ID of the AWS instance, and I wait for that to be running. I wait for SSH to come up, once again using output from that first action. And then once the SSH is up, I go and I fetch all of the deployment artifacts and I deploy those onto the system. And so I'm able to take this workflow here, and if this fails, I'm able to pump this into our chat room of choice and say, hey, we've broken the SD2 Express repo. Let's go back and let's take a look at that. And so it allows us to build a fairly easy to use CI/CD pipeline using a couple of different workflows. And the general idea is that and I'm going to dig into rules and triggers in a moment, but the general idea is that there's a sensor that watches the repo and will emit a trigger into our system that will fire off the tests, which in turn fires off the deployment of the Express environment, if you will. I've shown a lot through our UI, which is very, very early stage here. How do you phrase that, Evan? Would you say that's a closed alpha at this point? If you contact us, we give you access to the repo?
Yeah, I think that's fair. We are open sourcing it, just we want it to mature a little more. So look for it freely available next month. But if you ask, we will give it to you as well. We just request feedback.
Yeah, we're looking for feedback. So if there is anybody that's looking to use our system and does want to try the UI, please just contact us via our support Google group or on IRC, and we'll get you access to the UI. But the other part I'd like to show, which is the fully fleshed out and the very stable user interface, is our command line interface. So the command line utility that you get out of the box when you install StackStorm is called st2. So if we do an st2-h, we can see all of the different pieces of the system that we have access to through the command line utility. So we can see that we can actually look at all of the sensors that are running. We can get all of the triggers that have been registered in the system, any rules, actions, anything like that that's been registered in the system, as well as the full execution history, and we can manually invoke action. So I'm going to go ahead and start by showing you guys the sensors that we happen to have running in this system. So I just simply do an st2 sensor list. And we can see that the sensors that I have running in here are there's a generic webhook sensor which comes pre-installed out of the box, as well as a timer sensor. And the timer sensor it's very similar to cron or firing something off on a specific date. I've also installed a Jira sensor to watch for new issues in Jira, and then the Git sensor, which watches for changes to a particular repo. The sensors themselves are pieces of code that run within the system, and they are what sends what we call triggers in. Triggers are what the rules engine uses to decide whether or not it's going to automatically fire off actions or workflows. So if we look at the trigger list, you can see that I have a handful of triggers that I have registered in the system here. I have an event handler for Sensu, and that is what I use to do things like that OpenStack remediation. Sensu will fire in events that match this particular trigger, and then I'm able to go write rules that will match against this, and I can show you guys the rules here. Same thing with the Git sensor. I watch the Git repos, and I get triggers emitted into the system from the Git sensor that match this trigger name. So I only have a handful of rules in this particular system, but if we actually take a look at these rules, select a little bit cleaner output. So this particular rule is what's watching the StackStorm repo itself, and this is what triggers off the StackStorm building StackStorm. So what we're actually looking at is we're looking at that same trigger, or that same trigger type here, which you can see that's the same name that was listed above, and we're looking for any criteria. We then go, sorry, I actually grabbed the wrong rule. There we go. This is the actual rule that we want. So this is actually what, like I said, watching against the repo, and then it goes and it actually fires off that st2 test workflow which I had built, and passes in a number of parameters. The repo parameter and the hostname parameter where I want to run the test, I've hard-coded into the rule, but the revision, target, and author are actually parts of the payload that were emitted by the trigger. So when the sensor decided that certain criteria were matched and it sent a trigger into the system, it sends a payload in. And in that payload there's fields like the revision ID and what branch it was and the author and all of those things. So I pump those through to the st2 test workflow, and it allows me to execute those actions. So now, knowing that we have the sensors in the system, the sensors emit the triggers, and we can see how the triggers can be mapped via rules, we can actually take a look at the st2 action list. I have quite a few actions registered in this system, so this is going to be pretty big. So we can see that I have a number of Sensu actions registered in the system, as well as my build actions registered in the system. and a whole bunch of AWS EC2 actions registered in the system. But the particular action that I wanted to show you today is actually that SP2 tests workflow. So if we do an SP2 action get, and -J allows me to output anything that I can from the system in JSON format, which makes it a lot easier to automate the automation, if you will. So we can see this is that action that was being fired by the rule, and here are those parameters that we had defined, that we had passed in from the rule. So host name and target and author and revision. And so the action itself is actually looking for those parameters, and so that's why we map those from within the rule. This particular workflow is defined in our system here. I'll show it to you. So this is just a chain of actions that are being performed. The reference ID is actually the reference that you saw within the action library. And so each one of these links within this chain is just performing an action that was already registered from within the system. And then it passes in all of those parameters. The parameters are once again templatized and all that, and so it becomes very easy to use. That was kind of, these are more advanced examples of how our workflow works, but it really can be something as simple as just a basic shell command could be an action that you register with the system. Let's see what else I can show.
Just quickly,
go ahead, Evan.
Patrick, I think that's maybe to us a pretty obvious point that you can start small and then grow this over time. You can start with your existing scripts, as I mentioned. You can start with, obviously, the actions from the community, and the number of those is increasing, I don't know, exponentially. I mean, there were almost none, and now there's a couple handful, at least, including some VMware initial vSphere ones, AWS, pretty much any cloud, thanks to libcloud primarily. But then you can tie them together, and you can start to do more advanced things without losing, we hope, the transparency that is sort of inherent to this approach, this infrastructure as code approach, and to the tool itself. So I had a chat yesterday with a user who started with us in this kind of use case, CI/CD type use case, and is now starting to use us in this day 2 troubleshooting. And he was referring to it as Emergent Automation, which sounded a little buzzwordy, but I think the point is bottoms up. As you do stuff, you figure out I can automate it. I already did some automation tied together, as opposed to top down. What's your ITIL process going to be? Not to say that we can't get you in support of idle processes, but that tends to be a more heavyweight top-down approach as opposed to the operator SRE automator up approach that we're hopefully demonstrating here.
Yes, yeah, that's a very good point, Evan. Yeah, I've shown a number of different metadata artifacts, as we call them here within the system. That's kind of to illustrate the point that Evan had touched on earlier, that every aspect of what is registered within the system gets dropped to code. As we move forward, we're doing most of them in YAML these days, but we started off with JSON, which I've seen a number of JSON artifacts here. But the idea is that we didn't want anything that you couldn't version control. So all of the workflow definitions, all of the metadata around the actions, all of the trigger definitions, all of those things are written in either YAML or JSON. So you can version control those separate from the underlying code artifacts and things like that. It allows you to do a lot more around refining your process, and gives you a lot more visibility into the actual procedures that are being done around the actions, instead of abstracting away those things within code themselves. So that's very important. And the other aspect to the infrastructure as code piece that we've really focused on is that these examples have a number of steps to them, and I'm trying to illustrate the power of the workflow. But it's also very easy just to write a simple action and add in a script if that's what you have. If we look, and I wrote it this way on purpose, but if we look at this git clone.json example, the only thing that's really required within this is the name, description, runner type, and entry point. None of these parameters are actually required to get going. So you have like a 5 or 6 line JSON file to get your script added into the system, and you're now able to provide that visibility and that accountability for that script across the board for your team and for other teams. Really help with things like postmortems and things like that to see exactly what happened when.
Do you want to touch on your utility? Is it? I'm not sure the official name, the Voodoo utility, but just mention that briefly.
Yeah, I can. I was going to dig into the running an action manually in the system really quick to show the simplicity of that. Out of the box, we ship with the ability to run both local commands and then remote commands via SSH on hosts with what we call our core pack. So if we look at the core pack, we ship with, there's local sudo and remote. So if I wanted to run one of these actions, I could do st2 run pack name core dot action name, so core.local, and then just the command I want to run. And then it gives me the output from that here. There's the standard out that I would have gotten from just running date off of the command line. The difference between running date off of the command line is that this is fully audited, and this is fully tracked through the system and all that is the whole who executed what when. And then I can also always go retrieve that from the execution list. Grab that ID right there. And I have that same output here. So that's one thing that we really pushed hard for, is the ability to have this audit and this history, so you can go retrieve whatever the results were from actions that you had previously executed. I think that's a huge leg up from the classic repo of scripts that you see a lot of the time on ops teams. That's really the kind of the last point and last thing I really wanted to show within the system here. What Evan's talking about with what we joke about is the Voodoo, the Voodoo library, is there is within, we have a couple community repos out there. We have our SC2 contrib repo, which is our stable integration packs. And then we have another one that we call our incubator, where we put things as we're working on them. In the incubator, we've got I believe it's there. If not, it will be as soon as we're done with this. But there's a pack or a script called our Voodoo script, which will actually automatically generate actions based off of functions or methods within Python modules. It's pretty neat. It goes through and automatically introspects, and that was how I generated the 130 some odd actions for the EC2 connection class. I didn't write all that metadata by hand, I'll tell you that. We were able to go through and run this utility to automatically generate action. We can do the same thing for the various Salt client classes, or for OpenStack. We've done it for DigitalOcean. We've done it for a number of other things like that too, and it actually works really well to help you generate that metadata automatically, and then just a little bit of tweaking around the script pieces, and you have a really powerful library of atomic action. That's that about wraps up my
Good.
part of it, unless you thought I missed anything that I should cover.
I think that's great. Can you kick it back, or I can take it back? And
yeah.
You know, the repos that Patrick's talking about, probably an obvious point, but they're at, you know, GitHub/StackStorm, and take a look. Take a look. You know, if you click that star button, you know, every time you click that star button, somebody that works at StackStorm smiles. So just keep clicking or keep smiling. But do take a look. So this is what we've shown you. A couple of demos, and hopefully started to illustrate the why. Why the heck did we go down this path? Why do we have sensors? Why do we feel the need to be able to make sense out of events? Why do we have workflow? Quick plug for the January meetup. In the January meetup, we will actually be collaborating with a company called MoogSoft. MoogSoft is in some environments that we've seen that are absolutely large, where you have thousands of events potentially per second, and where the question is, which of these events is actually informative of something occurring? And so in their case, they apply some artificial intelligence and machine learning, guided and unguided, to actually do pattern identification. And so what we're going to demo with them, as you might imagine, is a complete remediation of at least one of what they would call a situation, which is what you get when you sort of dedupe out the events and apply machine intelligence to them. So, so we don't have to be, you know, making sense out of all the events. Very happy to work with products who obviously are built, or your existing event pipeline, whatever that may be, to make sense out of those events. But we need some conditional logic to be able to process those events, and we do have that, and hopefully we showed that to you today. What else? Questions? You know, again, hopefully we showed you why we're around. What does it do? How does it work? 2 demos for the price of 1. And I sort of joked about it, but yeah, give us a star. Try it out. Tell us what you think. We're on 0.6. We are in a whole bunch of, I would say, POCs, maybe loose production environments today. Some of the input that we're looking for is not just about the platform, but about these integrations, whether on the sensor side or the action side. And we'd ask you to, you know, tell your friends and ask them to tell friends as well. That's really how this is going to happen, how we're going to avoid all of us running into the same problem, which is what we're seeing. Again, 95% of the automations that tie events to actions today are scripts. Scripts are great until they aren't, and you have the technical debt of automation issue that we beat pretty hard in this discussion. So please, you know, take a look and give us your feedback. You know, give us a star or 2 as well. Obviously, I'm joking about that hashtag, but you know, tweet about us, get the word out. Feedback of any type is really welcome. See if there's some comments right now. Any
those comments.
questions?
Yeah. Thank you very much, Evan. Thank you very much, Patrick. And in case any of you guys have any questions, we still have a couple minutes left, so feel free to ask those. While you were speaking, Evan, I shared the web page for the upcoming session. Just to let you know, guys, we are going to have 4 sessions, a total of 4 sessions with StackStorm in 2015, 1 session per month. So in case you have any questions or any topics that you would like to see covered in those sessions, feel free to comment on our meetup.com page. And in the chat section, you also find the community page, StackStorm community page.
Yeah, and again, as you can see from even the next one, which is about remediation, each of those, as Raphael knows, are going to focus on each of those meetups let's actually do something. Let's show StackStorm doing X. Because while it's a fairly powerful automation platform, we think, obviously folks want to get a job done. And so remediation is one, or facilitated troubleshooting is one job people are using us for, CI/CD as well. Can you see the couple questions? Yeah, I think the links will be provided to the attendees. Is one question. So these links that Raphael posted in chat, we can provide those to the attendees, right?
Yes, exactly. Everybody will get them. And for all those who join us later or would like to review the presentation, we will share both within the next 24 hours with you guys.
Okay. There was a second question about the topology view of the whole. We do have, and Evan flashed it up briefly, we do have an architecture diagram that is available through our docs site. I don't have that instantly available, but we can make that available. And I believe that answers those questions. If it doesn't, then we are perfectly willing to dig into that further with you and help you figure out exactly what that means. If this diagram doesn't explain it, then we'd like that feedback.
Yeah, I may have been talking about more of a real-time view, and now I'm interpreting the question and making it more difficult. And you know, the quick answer is we do not do overall environment visualization. Speaking of visualization, not the exact question, but we are, the GUI will have more in workflow visualization and our results visualization here in when it's released in January. So you will see more of that. But if you're sort of running your NOC, as I used to back when I ran a NOC all too long ago, you know, off of a visual view, that we would then need to basically do northbound integration into that view. We don't provide you with sort of a, if you will, a Visio type view of your environment and where we're actually executing. Not sure if that was the question or if I sort of belabored it, but yeah, in some of these existing environments where they have existing panes of glass into their environment that they obviously have put a lot of thought and IP into, in that case, you know, StackStorm runs behind those and is really, I mean, that could be also, by the way, on the provisioning side, as Patrick knows, we have a large IT POC where they have 35,000 VMware VMs running, something like this. And of course, they have a portal on the front saying self-service. Here's how you as an engineer or whomever provision yourself. And we're just the engine behind that, and we're viewed more, you know, by the operators in that case as opposed to the tenants. It's analogous to the point that if you have a topology view of your environment, we would need to plug into it. We wouldn't, you know, we wouldn't replace it. We would hopefully just give it some more interesting information, like what automations are being run, and what actions could you be taking, and you know, it would be a cool integration to do. It should be very doable, but that conceptually is how you would do it.
All right, guys. Sorry, go ahead, Patrick. I think you want to say something.
No, I was just concurring with Evan. I was just saying yes, that's correct.
Well, thank you.
Right,
I see some folks are dropping, and I just want to say thanks to you, Raphael, and thanks to everybody to weighing in. And please, you know, do spread the word and give us any and all feedback. Really appreciate it. And you know, this is a really incredibly exciting time to be doing DevOps, or whatever you want that phrase can be. Yeah, I mean, we just have a question. You know, you can automate. Can StackStorm automate tasks for testing cloud services and business logic, not just DevOps? And the answer is absolutely. I probably should have mentioned the IT case before, because that's a fairly traditional use case, but it's one in which the maintenance overhead of the legacy workflow underneath this self-service provisioning piece was starting to drive the automation and operations team at this particular customer user insane. So, they've already sort of grokked, hey, shit, if the automations are just code, that'll make my life easier. But the targets, what we automate, in this case, ESX basically, what we integrate with some very interesting access control systems, et cetera, all of that is there. We're not saying, replace it. We're not purely a greenfield solution. We play nice with others, even if the others themselves are not built from the ground up for DevOps. That's a quick answer. That's a long answer, a long way of saying yes to that question.
All right, guys, thank you.